Now here we have the question: find the equation of the tangent and normal to the parabola y square equals to 4ax at x1 y1. uh, Also find the equation of normal in m form or slope form. हामीले इक्वेसन अफ टेन्जेन्ट र नर्मल निकाल्ने सँगसँगै नर्मलको इक्वेसनलाई स्लोप फर्ममा एम फर्ममा निकाल्नुपर्छ। यसका लागि सपोज इफ दिस कर्भ represents a parabola, then suppose this is a line which touches the parabola y square equals to 4ax, and this is tangent. Any line which touches the curve is called tangent, and the line which is perpendicular to the tangent at the point of contact only is called the normal of the parabola. Okay, we have to find the equation of tangent and normal at this point, which is given to us x1 y1. So here we have the solution. The given equation of parabola, the given equation of parabola is y square equals to 4x. Also given point on the parabola, on the parabola 1 is x1 y1. Also given point on the parabola 1 is x1 y1. So we have y1 square equals to 4ax1. Let it be 2. To get the equation of tangent, now we differentiate 1. Differentiating 1 with respect to x, we get d by dx of y square equals to d by dx of 4ax हुन्छ, or 2y dy by dx equals to 4a into dx upon dx. Therefore dy by dx equals to the derivative of this function is 2a by y. Derivative of this function y square equals to 4ax is dy by dx equals to 2a by y1. Also dy by dx at x1 y1 equals to 2a by y1. Here dy by dx represents the slope of tangent. So the slope of tangent at this point x1 y1 is 2a by y1. Now equation of tangent at x1 y1 to the given parabola is y minus y1 equals to dy by dx at x1 y1 into x minus x1. Here also dy by dx at x1 y1 equals to 2a by y1 equals to slope of tangent. Also dy by dx at x1 y1 equals to 2a by y1 equals to slope of tangent at x1 y1. Now the equation of tangent at x1 y1 to the given parabola is y minus y1 equals to dy by dx at x1 y1 into x minus x1. That is y minus y1 equals to 2a by y1 into x minus x1. On simplification yields y1 minus y1 square equals to 2a into x minus x1, or y1 minus, here we have the value of y1 square equals to 4a x1, so 4a x1 equals to 2ax minus 2ax1, or y1 equals to 2ax minus 2ax1 plus 4ax1, or y1 equals to 2ax plus 2ax1. Therefore y1 equals to 2a into x plus x1, which is the required equation of tangent, which is the required equation of tangent to the parabola y square equals to 4ax at x1 y1. Here slope of tangent at x1 y1 equals to 2a by y1. Therefore slope of normal at x1 y1 equals to minus 1 upon slope of tangent equals to minus y1 by 2a. Then equation of normal to the parabola y square equals to 4ax at x1 y1 is, then equation of normal to the parabola y square equals to 4ax at x1 y1 is y minus y1 equals to minus y1 by 2a into x minus x1. As we know that the equation of the line which passes through the point x1 y1 with slope m is y minus y1 equals to m into x1 y1 x minus x1. त्यसैले कुनै यो 1 पोइन्ट भएर जाने लाइनको इक्वेसन पोइन्ट स्लोप फर्ममा हाम्रो y minus y1 equals to m into x minus x1 को फर्मुला लगाइदियो. Here minus y1 by 2a is the slope of normal. त्यसैले this is the required equation of normal हुन्छ. Which is the required equation of normal to the given parabola. Let it be the equation 3. Now the last part of the equation of normal in m form. Okay, now we have to find the equation of the normal in m form or slope form. Slope form ma equation of normal के हुन्छ त्यो derive गरौँ. Here slope of normal, say m equals to minus y1 by 2a. Minus y1 by 2a from 2 that is y1 equals to minus 2am. While making cross multiplication, here it is m equals to minus y1 by 2a, cross multiply गर्दा y1 equals to minus 2am भयो. अनि from 2, now from equation 2, minus 2am square equals to 4ax1, or 4a square m square equals to 4a x1, therefore x1 equals to am square. इस प्रकार हामीले x1 र y1 को भ्यालु निकाल्यौं. Now substituting the values of x1 y1 in equation 3. Then from equation 3, we get y minus 2am equals to minus y1 by 2a is the slope of normal, so we can write m, and x minus am square, or y plus 2am equals to mx minus am cube. Therefore y equals to mx minus 2am minus am cube, which is the required equation of normal in m form. Required equation of normal in m form or slope form. In this way, we can find the equation of normal in m form, like y equals to mx minus 2am minus am cube. Equation m को टर्म मा भएकोले यसलाई m form भनेको हो, where m represents the slope of normal. Now we have another question. The question is that find the condition for a line y equals to mx plus c to be tangent to the parabola y square equals to 4x. In this question also, then I want to add one more question here. Also find the equation of tangent. Here is the question. First of all, we have to find the condition that the line y equals to mx plus c to be tangent to the parabola y square equals to 4x. Then we have to again find the equation of the tangent in this condition. So we can solve in this way. Here, given equations of line and parabola are y equals to mx plus c, let it be 1, and y square equals to 4ax. Number 2, solving these equations we get mx plus c whole square minus 4ax equals to 0. यहाँनिर y को ठाउँमा हामीले mx plus c को भ्यालु राखिदियौं, त्यो गर्दाखेरि mx plus c को होल स्क्वायर भयो, अनि यो 4ax लाई लेफ्टमा ल्याऊ, त्यसपछि हाम्रो यहाँनिर 4x mx plus c को होल स्क्वायर minus 4x equals to 0 हुन आयो. Now again solving this equation, or using whole square formula, m square x square plus 2mcx plus c square minus 4ax equals to 0. Therefore, m square x square plus 2mc minus 4a into x plus c square equals to 0. Therefore, m square x square plus 2mc minus 4a into x plus c square equals to 0. Now this equation is quadratic in x and gives the two values of x, and the line becomes tangent to the parabola if two values of x are real and equal. In grade 11 we have studied that if a line, if the roots of the equation are real and equal, in this case line becomes tangent, and the condition for which is its discriminant must be equals to 0. For example, if ax square plus bx plus c equals to 0 be any quadratic equation, and the roots of this equation are equal only if b square minus 4ac equals to 0. यदि कुनै क्वाड्रेटिक इक्वेसनका दुईटा रुट इक्वल छन् भने त्यसको के हुनुपर्छ, discriminant. This term b square minus 4ac is called the discriminant, and this discriminant must be equals to 0. हैन र now if the line, suppose if this is parabola and this is line, if this line becomes tangent to this parabola, suppose while moving from this point to this point, suppose this is a fixed point x1 y1 and this is another point, moving point on the parabola, then in this way if the point q, suppose this point is q and this point is p, if this point moves in this way, and here if q coincides with p, this condition is when q coincides with p, in this case the two values of in this case x2 equals to x1 and y2 equals to y1, in this case the line becomes tangent to the parabola. So this equation is quadratic in x and gives the two values of x. Now the line y equals to mx plus c becomes tangent to the parabola if two values of x are real and equal. The condition for which is the discriminant must be equals to 0. In this way, using this fact, we can find the required condition for a line to be tangent to the given parabola. This equation is quadratic in x, comma, yields two values of x, and the line y equals to mx plus c becomes tangent, and the line y equals to mx plus c becomes tangent to the parabola, to the given parabola, if two values of x are real and equal. The condition for which is its discriminant must be equal to 0. That is 2mc minus 4a whole square b square minus 4ac equals to 0, or 4m square c square minus 16amc plus 16a square minus 4m square c square equals to 0, or you cancel by 16a square equals to 16amc, 16a cancel, therefore c equals to a by m. Therefore c equals to a by m, which is the required condition, for a line y equals to mx plus c to be tangent to the given parabola. Again, the equation of tangent is y equals to mx plus a by m. C को ठाउँमा a by m राख्यौं भने we get the required equation of tangent to this parabola.